Alright, hello everyone and welcome to today's webinar. It's just now 2 o'clock, so I think we'll go ahead and get started. And the rest of everyone who's kind of just coming in will join momentarily. But my name is Roman Walsh, Application Engineering Manager here at SpaceClaim. On the line with Scott Zimba, Senior Application Engineer at SimWise, here to show you the new integration between our two products. So a lot of people who have been on SpaceClaim webinars in the past kind of know what we do, how we work. A really great tool for editing, modifying, changing geometry that you get in or you design from scratch, or you get in from other applications like STEP, IGES, SOLIDWORKS, or Pro-E. And today we're going to show you how we can work with geometry, modify it, change it, set up assembly conditions in order to do integrated 3D motion simulation. Now before we get started, we're going to go through a quick PowerPoint, show you the demonstration, and have a Q&A session at the end. So if you do have any questions on what we've shown today, SpaceClaim or SimWise, please don't hesitate to type them into the question box on the lower right-hand side of the GoToWebinar interface. And with that, I'm going to pass it over to Scott.
All right, thank you, Roman. Welcome, everyone. Welcome to the SimWise 4D demonstration and overview. What I'd like to do today is give you a good feel for what the product does and how it's tied into SpaceClaim and what its capabilities are. So the first thing I would like to talk about is the products that we have. SimWise 4D is comprised of mainly 2 core products, or 2 core areas. So the first thing we have is we have the SimWise Motion. And SimWise Motion allows us to study kinematic and dynamic characteristics of your SpaceClaim parts and assemblies. Very powerful tool. We have the SimWise Finite Element Analysis, or SimWise FEA. Allows us to look at linear static stress and deflection, natural frequencies and mode shapes, buckling, and thermal behavior for heat transfer characteristics. And then the real key feature that we have in terms of the product packaging here is the SimWise 4D, which is the combination of the motion and the FEA. And what we're able to do with that is we're able to run an analysis that combines both motion simulation and structural finite element analysis in one environment. Why simulation with 4D? Why the motion and the stress analysis? Well, stresses are typically very difficult to calculate when it comes to dynamic motion load situations. Peak loads don't always equal the peak stress. In one moment, a mechanism could be in pure bending, and the next it could be in shear. SimWise allows you to sweep through all those different configurations and determine what the peak stresses are and find the worst case scenario. So looking at the combination of the 2 products into the 4D, we can find that extreme condition and make the changes we need to our SpaceClaim model and study these what-if scenarios to design a better product. We are an associative add-in with SpaceClaim. So the data is transferred from SpaceClaim into SimWise, and we support all the geometry and all the constraints right from the CAD system. Any changes that are made to the SpaceClaim model will propagate down to the SimWise model. So this is a nice feature in terms of making the changes, running the analysis. Maybe you have to make a change to the thickness of a part or a constraint type. We're able to reflect that down in the SimWise model, and only the changes are sent, which makes the process run very quickly. Some of the key product offerings we have with SimWise is we have the combined motion and FEA. That's something that you don't see in some of these packages that are on the market today. This is the real benefit that we have in one environment. We're associative with SpaceClaim, as we just described in the last slide. We support neutral file formats very cleanly, ASYS, STEP, Parasolid. We have high definition rendering and animation, and annotations and dimensions. These are great tools that tailor towards sort of the marketing side of the product. Once you've got the analysis done and now you're creating, say, these videos for a design review and putting information on the screen that's not too complex and doesn't confuse a certain audience. So it tailors to that sales and marketing side for your company. We have powerful formula language and function builder capabilities in terms of bringing data in through Excel, let's say table data, writing your own mathematical functions and things like that. We have a wide array of capability in that regard. We have an API for customizing the program to tailor to your needs. If there's a certain task that you do on a day-to-day basis, you can customize SimWise to help meet those, stay within that envelope of what you're doing and sort of automate your process of building your model and running your analyses. We're integrated with Simulink, so if you're integrating, say, control system feedback into your simulation model, we have what we call a plant layout, and it directly links with Simulink, so we can get that real-time data exchange between the two products. Coming later this year, we're working on optimization so that we can optimize our outputs and inputs to meet certain criteria for the simulation. So for today's demonstration, what we're going to do is look at some of the basic capabilities. The software is loaded with nice features. Obviously, we're limited to time here, so we're going to try and keep it broad, but yet focused enough on some of the key features that you might find interesting. The mapping of the SpaceClaim constraints. We're going to take a look at some actuator inputs and some of the structural loads that will apply in here. We'll look at some of the output capability. We'll be able to solve a motion and FEA together, and then we'll add some of these dimensions and annotations that we discussed earlier, and then finally create a video and some photorealistic imaging. What I'm going to do is toggle over to my SpaceClaim model. So I have the gripper, which many of you are probably familiar with. This model is fully constrained in SpaceClaim. So for example, if I click on the piston subassembly here, and I'll click on my move command, and I'll drag my piston up and down, we can see that we have the constraints properly in place. What I'll do is go ahead and specify a new position for my piston here, and we'll leave it in the open position. And then I'll click on the SimWise tab here on the top menu, and then I'll click on Export. And what this did is this brought my model into SimWise, so now I've switched my environment here. And the first thing I see is a list of all the bodies and constraints that were mapped over into SimWise. So I'll clear that out of the way. And I'll come back to this Constraint Navigator. This is a real useful tool for understanding the connectivity of the parts in your model. I'm going to hide this part right here. And just to show you how quickly we can get into a simulation, I'm going to go ahead and change the actuator to the constraint for the piston to an actual actuator. So if I double-click this constraint, it's telling me what type of constraint it is now. I'm going to change it to a linear actuator. And then I'm going to specify that it's a displacement actuator. And I'm going to define a simple step function for that. And I'm just going to say that we're going to sweep through a displacement of 50 millimeters over an interval of 2 seconds. I get a preview of what that data is going to look like into my model. And then what I'm going to do is define a stop control. If I don't define a stop control, the simulation will just run indefinitely. So I'll go ahead and stop it just after time is greater than 2 seconds. And then before we launch the simulation, let's put something of interest on the screen. Let's just verify our input function. And I'm going to click on that actuator and insert a meter that monitors the constraint displacement. So if I go ahead and click my Run button here, and my simulation is complete. So if I double-click my plot here. I'm going to go ahead and hide the other XYZ components, so I'm only looking at the magnitude of this. If I drag my slider bar, I get a tracer that appears on the plot and shows me the data point that corresponds to the model position. So let's take this a step further now. Now that we know we've got our constraints in place properly and we've got our actuator applied, let's go ahead and let's apply a structural load. I'll click on my force button here, and I'm going to apply a load that acts on the tip of this jaw, and I'll do the same for the other one. Once those forces are where I want them, then I can click both of them and open up the properties. The nice thing is I can modify several features at the same time. So for both of these forces, I'm going to specify it's a structural load. I just noticed that I'm not interested in applying these units in terms of dynes. So let's go ahead and quickly change the unit type to newtons. And then we'll go back to our forces. And then we'll specify that force to act normal to that face, and we'll give it a value of, say, 1,500 newtons per force. And then before we run this next simulation, we're going to take a look at a key piece of data. So this is a nice example of how SimWise helps you reverse engineer information. Let's say, for example, down here, we're going to clamp with a certain amount of force. We know that that's going to be 3,000 newtons total. We don't know what the input needs to be on our actuator to achieve that clamp force down here. So rather than cycle the actuator with a given force and try to determine what we're able to clamp with, we're doing just the opposite of that. So let's click the actuator here and let's insert a meter, which monitors the constraint force for that. Now I have my displacement meter and I have my actuator meter, or for the force. And for the displacement right here, another thing I can do, or for any meter for that matter, is I can change this to a digital readout as well. So let's go ahead and let's run the simulation. And it's complete. Like I did for the other one, I'm just going to activate the properties for this meter, and I'm going to hide the other X, Y, Z and components. So I'm just looking at the magnitude of the force. So I can see that the maximum point here occurs right at about at this position. Okay, so it's not a constant linear input versus output nature here. So it does have a different range. Okay. The other thing we can do is, I'm going to go ahead and rewind that. And we have gravity in here. Currently, gravity is acting perpendicular to the face of the model here. We can see our little orientation indicator. It's simple enough to change the direction of gravity by a couple clicks here. So now we can see that we're acting in the negative X direction. We mentioned before that one of the key benefits of SimWise is the ability to do simultaneous FEA and motion simulation. So what I'd like to do is I'd like to study the stress in this arm right here, or this jaw as I've called it in the model. So I'm going to open up the properties for that, and I'm going to include that body in FEA. I'm going to go ahead and assign a mesh size to it, and I'm going to go ahead and have the program automatically refine it initially because we've got some small fillets in there and some sharp edges. We want to get some decent elements. So let's just create an initial mesh on this, and then we'll see what it looks like. So now what we'll do is we'll select our Run button, and we'll change it to the Motion with FEA option. So if we go ahead and run this now, the program is solving simultaneous motion in FEA. With your typical FEA packages, what you have to do is you have to manually apply your loads as boundary conditions. And you have to gather that data from a kinematic or dynamic analysis. So there's a disconnect in the information between the two. With this, we're able to do it simultaneously, which is a real key advantage. Once we find the worst case scenario for this arm right here, like I said, we started with a basic mesh. Once we find the worst case, we can refine our mesh, and we can use something called H-adaptivity. So let me pull up that slide there. H-adaptivity allows you to take the mesh and refine it only in the areas that it needs to. So in this slide right here, you can see that we specified a target error of 5%. We've exceeded that criteria, or that convergence, by meeting it with 4.63% in only 2 iterations. So once we find the maximum worst case condition, the program will automatically refine it, and then we're converging on a more accurate solution for the FEA. Let's go back to our SimWise model here. Now it's complete. And I'll just click and I'll drag my slider bar. And then another thing I'll do is I'll just click on this body and insert a meter, which takes a look at the von Mises stress, or the maximum stress in the model. So we can see that normally these would be several incremental snapshots in time. We've got the whole range of motion in here throughout the mechanism's cycling. So then what we could do is we could stop it at a particular point. We could turn on the H-adaptive method, and then we could run H-adaptive. So in the interest of time, that's why I pulled up the slide. But the process is very quick. I think to run this only takes a minute or so. We have other tools in here for traditional FEA manipulation. Those be, say, probing different points around the model, cutting sections through it, plotting factor of safety, and we can plot different components and things like that in terms of the FEA. What I'm going to do now is I'm going to go ahead and set the model back, and I'm going to erase the FEA history on this. And I'm going to take a look at some of the annotations and dimensions that we discussed earlier. I'll just enlarge the model here. And just for clarity, I'm going to go ahead and I'm going to hide these constraints that are showing in the model so that we have only the bodies. SimWise is very friendly in terms of changing colors, controlling the visibility of only certain components, using transparency and things like that. So I'm going to select all these bodies and say that I'm only interested in looking at those, so let's hide all others. Okay. Let's hide it that way. I think I had the top level assembly connected, was causing a problem. Okay, so let's go ahead and let's put a dimension in here. We've got our dimensions and annotations up here. I'll click on the dimension tool. It automatically recognizes and filters out the arcs and things in the model. So I'm going to put a dimension that monitors the distance between the bottom of the piston and the bottom of the cylinder. It's small right now, but once we run the simulation, we'll see it change in size. We'll add another dimension for, say, the distance between the jaws. And then we'll add an annotation here, and we'll just tie that to the piston. And the annotations are very, very powerful. Like I mentioned before, if this was being used in a design review or a marketing presentation, people might not necessarily want to see a lot of engineering data. It might be confusing to them. With this, we're able to customize formulas and things into these annotation callouts to make it easier to understand. So what we'll do is we're going to add an annotation, and this is going to be a real-time math-based annotation that reads the mechanical advantage or the input versus output ratio of the clamp. So we have our function builder here, and I'm going to look at the take the constraint force, constraint 154. That was the constraint number for our actuator. And I'm going to look at the Z direction, and let's divide that by the total amount of clamp force on the jaws. And then we'll specify a name. And we'll enter that, and there is our annotation. So if we now go ahead and we run the motion analysis, we can see it's a negative ratio because there's more force required in the actuator than we get out at the jaws. We also have a closest distance tool, which is great for understanding the minimum clearances between bodies. Some of the, I mentioned earlier, when we first came into SimWise, there was a constraint navigator tool. So if I right mouse click, I can pull up the constraint navigator. This is a great tool for understanding the topology of the model. So if I click on this insert, for example, it only shows me the parts that are tied to that insert. I click on the links and so on. So this is a great way to see if I have parts that are not connected properly. Another tool we have, I'll turn off the constraint navigator, is the kinematic view. And I have this body showing because it's still included in the FEA. Let me turn that off. And because it's showing a mesh. Okay, so the kinematic view is basically a large free body diagram of your model. So another great way to understand if things are connected properly. Now that we have some basic information on the model, let's go ahead and let's take a look at some of the photo rendering and the photorealistic animation capability that we have. So I'll click on the rendering icon here to bring up my rendering properties. And if I just click on preview, it'll show me currently what I have. So we can see that we've got a pretty small window for the preview right now. This is not necessarily when I want to save off. Let's change our dimensions to something like 1300 by 900, and then we'll preview that. And we can actually zoom in on the model as well, and that will change the size of the model in the preview. So this creates nice photorealistic images. You notice we have reflections, we have shading in here, and we can save that off to a file. The other thing we can do now is we can save an animation of this, but before I do that, what I'm going to do is show you some of the keyframed animation capabilities we have. I have a camera icon over here. If I select that, that brings up my camera and light properties. I can add spotlights around the model. I can add cameras that are attached to certain bodies and only track certain bodies. So we'll just we'll start with the default here, and I'll move the model out. And then I'll double-click this camera to bring up its properties, and then I'll choose the keyframed option. Switch it to perspective mode. And we'll just get the model into some sort of a starting position here. And then what we're going to do is reset the model to our open jaw position there. Okay. And then we'll record this frame, and then we'll advance the model forward in the simulation, and we'll zoom in slightly, maybe pan over a bit, and then we'll record that frame. And I'll bring the model to the end, and I'll rotate it around a little bit, and we'll record that. So with a few clicks there, and I play this back, I've got a nice animation that I can save off to a video. Going back to the PowerPoint slideshow, I'd like to summarize a little bit on the product. We've got the integrated motion and stress analysis. So really the benefit is that we're answering the questions to will it work and will it break. So we're addressing the function and failure questions in one environment. And we're taking the guesswork out of load conditions for FEA. We don't have to be a full-time user of the product. This is not a high-end analyst's tool. It's meant to be the engineer's or the design engineer's tool where he can create a design, transfer it over to SimWise, do some basic analysis, understand if it's functioning properly, make the changes, do another analysis, and so on. It's easy enough to use, to pick up and run with, and not have to be very proficient with it all the time. It's very powerful. So it's easy to use but powerful, something that is hard to come by in some of today's tools. We've got a wide array of tools to mock up these physical prototypes. Not only is the built-in capabilities very powerful in terms of the formula language and the function builder. We have the Simulink integration. We have real-time feedback with Excel. And we have the API customization, as we talked about in the beginning. Fully associative with SpaceClaim. So we can quickly make those design changes, send the information back to SimWise, understand functional performance and failure potential very quickly. So with that, I'm going to pass it back to Roman and see if there's any questions. I've got a video that I'm going to go ahead and play in the background here while he's addressing questions.
All right, thank you very much, Scott. That was really, really informative. And I think what you said makes a lot of sense, just because the more you can learn about a model, learn about an assembly early on, and let simulation drive the actual design, that really helps companies save money and iterate much, much faster by doing some of that early on in the concept phase of design. But, again, let me remind you that if you do have questions, please type them into the chat box now, and I will go ahead and look at them. So one of the questions that I've asked is how do you handle collision detections? Scott, can you comment on that?
Yes, that's a good question. I'm going to pause this model just so it doesn't interfere with our work back in SimWise. Yes, we handle collision detection, and it's very easy to work with. It's simply a matter of selecting one or more, or two or more bodies. So, for example, I will select two bodies here, right mouse click, and I can say that they collide. I can define friction characteristics between them. I can define their elasticity, whether they're behaving like steel or more like neoprene. Okay?
Got it. So another question is just about somebody asked, how do you get it? I assume that the contact information slide that you had displayed will display how you can get it and more information on that. And there's also a few questions on the price of SimWise. I don't know, do you want to comment on that, or should they just contact you?
Yeah, they can contact us. But what I'd like to do on that note, Roman, is I would like to bring up a slide I have. Let me open up I have a licensing slide here, and this explains the different licensing options that we have. So we've got the node locked, which is tied to a specific computer. But the license can be revoked and moved to another one. So it's not just tied to that specific computer. We've got the USB dongle that also can be moved around, and then we've got the traditional network and floating client arrangement where the license is checked in and checked out as the program is started. We also have a 12-month lease option as well.
Okay, so if somebody's asking about the kind of the associativity, like let's say the cylinder diameter of the actuator or something changes, does that update in SimWise?
Yes, it does. All geometry changes will be reflected in SimWise, as well as any constraint changes. Let me do this. I'll be very frank and honest. I am not an expert. I'm not very proficient in using SpaceClaim to modify geometry. Motion simulation and analysis is pretty much what we do. But I will demonstrate a change that we can do in SpaceClaim, and we'll see how that propagates down to our model. I'll try and do that very quickly here in the interest of time. So I'll go back to the SpaceClaim model, and for example, let's say that we did not have one of these constraints in here. So for this jaw, if I take a look, we've got a whole series of mates that have been defined. I'm going to remove this align mate between that shaft and that housing, or the arm and that housing. I'll just go ahead and I'll delete it, and then I'll export my SimWise model again. And then SimWise tells me that a certain constraint has been deleted. I'm going to go ahead and say let's delete it. And I'm going to delete my keyframed animation because this is going to be it'll be moving around on me if I don't. Okay, so now if I run this, we still have our forces applied on here. Let me delete the forces and I'll run it again. So, for example, this is we have something that was missing out of the SpaceClaim model. So we can add a constraint in here to correct that. I suppose this sort of leads me into something I didn't show that might be a question that someone wants to ask, is how easy is it to add constraints in SimWise? And it's very easy. If you don't have a constraint already defined in SpaceClaim that's converted into a SimWise constraint, we have several constraints in here. You can see the list. We support the equivalent of the SpaceClaim constraints, and we have different names for them, but they're essentially the same degree of freedom type of joint. But we also have a lot of mechanical type connectors, such as the actuators and the motors, belts, gears, rods, separators, and we can even customize a certain constraint, and we can have constraints sort of break when a certain load is achieved or something like that. So we can do a lot of powerful things with them.
Great. And there's a lot more questions coming in. Please type them in, but there's a lot of questions on kind of more specifics on kind of the FAA part and kind of the codes and capabilities. And just to not get into too much detail now, you can follow up with them afterwards, Scott, because we only have time for one more question. And I'm going to pick one that I think is pretty fun. Somebody asked, why is it called 4D?
That's a good question. The 4D is because we're doing something that's not very traditional to analysis, and that is the simultaneous solution of the motion and the FEA.
Great. Well, with that, and we're kind of running a little bit late, and so what I typically like to do is I'll keep the meeting open for a few minutes. If you do have questions about SimWise, about SpaceClaim, about the integration, definitely type them into the chat box, and you will definitely be contacted and followed up with any questions you have on the tool. And also, again, if you do want more information on SimWise and want to contact them, it's info@design-simulation.com, and the phone number is on screen. Scott, thank you very much for an excellent demonstration on your software.
Thank you, Roman. Thank you, everyone.